Almost a year ago, my aunt started suffering back pains. She went to see the doctor, and they told her that it was a normal injury for someone that had been playing tennis for almost 30 years. They recommended her to do some therapy, but after a while, she wasn't feeling better. So the doctors decided to do further tests. They did an X-ray and discovered an injury in her lungs. And at the time, they thought that the injury was a strain in the muscles and tendons between her ribs. But after a few weeks of treatment, again, her health was not getting any better. So finally, they decided to do a biopsy. And 2 weeks later, the results of the biopsy came back. It was stage 3 lung cancer. Her lifestyle was almost free of risk. She never smoked a cigarette, she never drank alcohol, and she had been playing sports for almost half of her life. Perhaps that is why it took them almost 6 months to get her properly diagnosed. My story might be, unfortunately, familiar to most of you. 1 out of 3 people sitting in this audience will be diagnosed with some type of cancer, and 1 out of 4 will die because of it. Not only did that cancer diagnosis change the life of our family, but that process of going back and forth with new tests, different doctors describing symptoms, discarding diseases over and over was stressful and frustrating, especially for my aunt. And that is the way cancer diagnoses have been done since the beginning of history. We have 21st century medical treatments and drugs to treat cancer, but we still have 20th century procedures and processes for diagnosis, if any. Today, most of us have to wait for symptoms to indicate that something's wrong. Today, the majority of people still don't have access to early cancer detection methods, even though we know that catching cancer early is basically the closest thing we have to a silver bullet cure against it. We know that we can change this in our lifetime, and that is why my team and I have decided to begin this journey. This journey to try to make cancer detection at the early stages and the monitoring of drug response at the molecular level easier, cheaper, smarter, and more accessible than ever before. The context, of course, is that we're living at a time where technology is disrupting our present at exponential rates, and the biological realm is no exception. It is said today that biotech is advancing at least 6 times faster than the growth rate of the processing power of computers. But progress in biotech is not only being accelerated, it is also being democratized. Just as personal computers or the internet or smartphones leveled the playing field for entrepreneurship, politics, or education, recent advances are leveling it up for biotech progress as well. And that is allowing that multidisciplinary teams like ours try to tackle and look at these problems with new approaches. We're a team of scientists and technologists from Chile, Panama, Mexico, Israel, and Greece. And based on recent scientific discoveries, we believe that we have found a reliable and accurate way of detecting several types of cancer at the very early stages through a blood sample. We do it by detecting a set of very small molecules that circulate freely in our blood, called microRNAs. To explain what microRNAs are and their important role in cancer, I need to start with proteins. Because when cancer is present in our body, protein modification is observed in all cancer cells. As you might know, proteins are large biological molecules that perform different functions within our body, like catalyzing metabolic reactions or responding to stimuli or replicating DNA. But before a protein is expressed or produced, relevant parts of its genetic code present in the DNA are copied into the messenger RNA. So this messenger RNA has instructions on how to build a specific protein. And potentially, it can build hundreds of proteins. But the one that tells them when to build them and how many to build are microRNAs. So microRNAs are small molecules that regulate gene expression. Unlike DNA, which is mainly fixed, microRNAs can vary depending on internal and environmental conditions at any given time, telling us which genes are actively expressed at that particular moment. And that is what makes microRNAs such a promising biomarker for cancer. Because as you know, cancer is a disease of altered gene expression. It is the uncontrolled regulation of genes. Another important thing to consider is that not 2 cancers are the same. but at the microRNA level, there are patterns. Several scientific studies have shown that abnormal microRNA expression levels varies and creates a unique specific pattern for each type of cancer, even at the early stages, reflecting the progression of the disease and whether is it responding to medication or in remission, making microRNAs a perfect, highly sensitive biomarker. However, the problem with microRNAs is that we cannot use existing DNA-based technology to detect them in a reliable way, because they are very short sequences of nucleotides, much more smaller than DNA. And also, all microRNAs are very similar to each other, with just tiny differences. So imagine trying to differentiate two molecules, extremely similar, extremely small. We believe that we have found a way to do so, and this is the first time that we show it in public. Let me do a demonstration. Imagine that next time you go to your doctor and do your next standard blood test, a lab technician extracts the total RNA, which is quite simple today, and puts it in a standard analysis well plate like this one. Each well of these plates has specific biochemistry that we design that is looking for a specific microRNA, acting like a trap that closes only when the microRNA is present in the sample. And when it does, it will shine with green color. To run the reaction, you put the plate inside a device like this one. And then you can put your smartphone on top of it. If we can have a camera here, or so you can see my screen. A smartphone is a connected computer, and it's also a camera, good enough for our purpose. The smartphone is taking pictures, and when the reaction is over, it will send the pictures to our online database for processing and interpretation. This entire process lasts around 60 minutes, but when the process is over, wells that shine are matched with the specific microRNAs and analyzed in terms of how much and how fast they shine. And then, when this entire process is over, this is what happens. This chart is showing the specific microRNAs present in this sample and how they reacted over time. Then, if we take this specific pattern of microRNA of this person's samples and compare it with existing scientific documentation that correlates microRNA patterns with the specific presence of a disease, this is how pancreatic cancer looks like. This inside is a real sample where we just detected pancreatic cancer. Another important aspect of this approach is the gathering and mining of data in the cloud, so we can get results in real time and analyze them with other contextual information. If we want to better understand and decode diseases like cancer, we need to stop treating them as acute, isolated episodes and consider everything and measure that affects our health on a permanent basis. This entire platform is a working prototype. It uses state-of-the-art molecular biology, a low-cost 3D printed device, and data science to try to tackle one of humanity's toughest challenges. Since we believe early cancer detection should really be democratized, this entire solution costs at least 50 times less than current available methods. And we know that the community can help us accelerate this even more. So we're making the design of the device open source. Let me say very clearly that we are at the very early stages, but so far we have been able to successfully identify the microRNA pattern of pancreatic cancer, lung cancer, breast cancer, and hepatic cancer. And currently, we're doing a clinical trial in collaboration with the German Cancer Research Center with 200 women for breast cancer. This is a single, non-invasive, accurate, and affordable test that has the potential to dramatically change how cancer procedures and diagnostics have been done. Since we're looking for the microRNA patterns in your blood at any given time, you don't need to know which cancer you're looking for. You don't need to have any symptoms. You only need 1 milliliter of blood and a relatively simple array of tools. Today, cancer detection happens mainly when symptoms appear. That is stage 3 or 4. And I believe that is too late. It is too expensive for our families. it is too expensive for humanity. We cannot lose the war against cancer. It not only costs us billions of dollars, but it also costs us the people we love. Today, my aunt, she's fighting bravely and going through this process with a very positive attitude. However, I want fight like this to become very rare. I want to see the day when cancer is treated easily because it can be routinely diagnosed at the very early stages. And I'm certain that in the very near future, because of this and all the other breakthroughs that we're seeing every day in life sciences, the way we see cancer will radically change. It will give us a chance of detecting it early, understanding it better, and finding a cure. Thank you very much.